Okay, we're going to deal a little bit. Yesterday we talked about parallel lines, but then we didn't do anything else with parallel lines, did we? We talked about what parallel lines were, we talked about what skew lines were, and then it seems like we went completely off track to talk about something else. And so today we're going to get back to the parallel line thing. All right, so I'm going to draw a line right here, line down here, and there are parallel lines. Now, just looking at that, can you just tell by looking at it that they're parallel lines?
Yeah.
No.
Why?
Yeah.
Why are they parallel? Just because they look like it?
Because they can go forever and never touch each
Yeah, but how do you know they're not going to touch each other? How do you know that's not slightly slanted?
They're slanted?
I said this could possibly be slanted just a little bit, couldn't it? That you can't tell, right? And then you can't really tell if they're going to touch each other. So how do you know that they're parallel to each other? Or do you know that they're parallel to each other? Just by looking at these two lines. Why not? What did we talk about yesterday? How do we show parallel lines? I think we talked about that in here, didn't we?
You don't arrows at the end?
Not at the end, but inside here somewhere. Didn't we do this yesterday?
No.
We didn't? Must have been my other class then. Sorry. I was wondering why you guys weren't getting that. So if I put a little arrow right here and right here, you know what that tells me about these two lines? They're parallel to each other. Okay. That they are parallel to each other. Without those little red marks right there, I wouldn't know that they're parallel. Just because it looks like, just because you look on a sheet of paper or a worksheet or the book, and if they look parallel to each other, doesn't necessarily mean that they are parallel, right? But if they tell you, or they put the little arrows right here, then you could say that they're parallel. Let's call that line L and line M. Let's say they didn't have, let me get rid of all these little red marks. Okay, let's say they didn't have that on there. Can you just say that L and M is parallel right now? No, you can't. Remember, we just got finished about 5 seconds ago saying you can't say that they're parallel to each other unless they tell you. They could tell you a couple different ways. They could put the arrows in here, all right? And a lot of times in the book they'll make them a different color. They don't have to, but sometimes they do just to make it stand out a little bit. Or they could just tell you in the instructions. They could say L is parallel to M. That's the symbol for parallel. Do you see it? It's just two straight up and down lines. That's the symbol for parallel. So line L is parallel to line M. If they told you that, then could you say that they're parallel?
Yeah.
Absolutely, because they're telling you, all right? They have to tell you. You can't make any assumptions about these lines being parallel to each other. You can only go by the given facts. You got it? Okay. And so these two lines are parallel to each other. Let's draw a transversal through these parallel lines. Now this is a little different. Let me try it again. This is a little different than we talked about yesterday. Yesterday we just said the transversal cuts any two lines, right? Then you had corresponding angles, you had alternate interior, alternate exterior, consecutive interior. You had all those stuff going on, didn't you? This time there's something a little different. What's true about these two lines now? They're parallel to each other. Okay, so this is a big difference. It's a huge difference. So that is parallel to this. You got it? Now, I'm going to put those numbers in here like we did yesterday. Yep, 1, 2, 3, 4, 5, 6, 7, and 8. All right, looks pretty close to what we did yesterday, but tell me something about those two lines yesterday. They were not parallel to each other, right? Okay, so all we did was said, okay, 1 and 5 are what? What is 1 and 5? Corresponding angles, right? Okay, so that's all we knew. Remember I told you a couple times, I said we don't know anything about them being equal to each other. We don't know anything about, any kind of relationship. All we know is the name of those angles. All right, so 1 and 5 are corresponding. Let's just, for the fun of it, just go through some other ones. What about 3 and 6? What would you call 3 and 6? Alternate interior angles. What about 2 and 7? Alternate exterior angles. Good. What about 3 and 5?
Alternate interior.
They're not alternate. They're 3 and 5. They're consecutive interior angles. Okay? 3 and 5 are consecutive interior angles. Everybody got that? All right. We're going to use those words today, but we're going to say something more specific about these particular angles. This thing works only if the lines are parallel. We have things called if-then statements. So this whole thing says if the two lines are parallel, and I'm just going to shorthand it a little bit. Okay? Instead of saying the two, I'll just say if the lines are parallel, then dot dot dot. There's some things that we can say about it. All right. So are these two lines parallel?
Yes.
Yes, they are. How do you know?
The arrow.
Because the arrows right here say that they're parallel. Or you could look up here, and this tells me that they're parallel as well, doesn't it? So two different reasons why these things are parallel. You got it? So if the lines are parallel, then there's several things. There's actually 1, 2, 3, 4 different things that are true. Right? Remember the first thing we talked about was corresponding angles? 1 and 5. Give me all the corresponding angles. 1 and 5, 2 and what? 6, 3 and 4 and 8. If the lines are parallel, then, watch this. This is the first one we're going to learn. Then the corresponding angles, what do you think? Just eyeballing it. That's right. The corresponding angles are equal. Or in geometry, a lot of times we say, what? What's that little squiggle on top of the equal mean? Congruent, right. Okay. So I don't really care. Some teachers make a big deal that you always say congruent. I'm fine if you say equals. I mean, we know what you're talking about, right? So I'm fine either way. So if you want to say congruent, you can. If you want to say equals, you can say equals as well. All right. So if the lines are parallel, then the corresponding angles are equal. Now, according to this, we call this a postulate. I'm not going to get too detailed on this. This is called a postulate. It's kind of like a rule or a law, right? They say this is a rule that says, boom. But instead of using the word rule, R-U-L-E, we use the word postulate. A postulate is something that you cannot prove. Okay, it's just an accepted fact that we believe. Okay, so again, I'm not going to get too specific with this. In my honors class, we go into a little bit deeper on this, but in here we're not going too much. All right, but a postulate. This is our first postulate. If the lines are parallel, then what's true? Then the corresponding angles are equal or congruent. Let's just list, instead of listing just all the corresponding angles, now we can do something a little more specific. Now, instead of just saying 1 and 5 are corresponding angles, what can I say about angle 1 and angle 5? They're congruent to each other, right? And I'll tell you what, I'm just going to write equals. Is that all right? Because my squiggle's not too good. All right, so angle 1 is equal to angle what? 5. Okay, let's list all of them. So angle 2, what? Must equal angle 6. Let's say it, the whole thing. So what else? Angle, well, let's go in order. Let's go angle 3 is equal to angle 7. And what else do we have? Angle 4 equals angle 8. Don't just say 4 equals 8. Say angle 4 equals angle 8. All right? So this is a little different than what we did yesterday, isn't it? So now, what if I said this? What if I said angle 1 was 120 degrees? What could you tell me? You could tell me a bunch of stuff. You could say angle 5 is 120 degrees. Let's do some more. What about 4? What's angle 4 going to be equal to? Because of what reason? Because vertical angles are equal. That's right. Remember that? That's something we talked about a little while back. So watch. 1's equal to 4 because of vertical angles. 1's equal to 5, right? What else do you think you could say is equal? 5 is equal to what? 8. For 2 reasons. 5 is equal to 8 because of vertical angles. I shouldn't say for 2 reasons. 5 is equal to 8, and 4 is also equal to 8, isn't it? Why is 4 equal to 8? Because they're congruent for what reason, though? Because of corresponding angles. Right, because they are corresponding angles. And what's true about corresponding angles? They are what? They're equal or congruent. Only if what? There's a big if right there. If the lines are parallel. That's the only way that they're equal to each other. If the lines are parallel. Does that make sense?
Yes.
Okay, so if the lines are parallel, then you can say all this stuff right here must be true and equal. Look, 1, 4, 5, and 8 would all be equal to each other, wouldn't they? You got it? Okay, that's pretty easy, isn't it? And you could also say, what about angle 2? And we'll put 2 arcs here to show the difference between. So angle 2 would equal what? Angle 3. Give me a reason for that. Why does 2 equal 3? Because of vertical angles, right? All right, vertical angles are equal to each other. 2 is also equal to what else? 6. Give me a reason. Because they're corresponding angles, that's right. What else? 6 and 7 are equal. Why is 6 equal to 7? Because of vertical angles. But look at this other thing too. Now that's all because of this postulate that corresponding angles are equal. You got it? And we kind of threw in a little bit of vertical angles in there as well. But check something out. 3 and 6. What must be true about 3 and 6? They both have 2 arcs on them, so guess what? They're equal to each other, exactly right. Because 2, 3, 6, and 7 are all equal to each other. So 3 and 6 are equal. What's the relationship? This is from yesterday. What's the relationship between 3 and 6? Alternate interior angles. So guess what else we can say? We can say if the lines are parallel, then guess what else is true? And then the alternate interior angles are also what? Equal or congruent. I'll put a little congruent there. Told you my squiggly's not very good. Alright, so the alternate interior angles are equal. Let's list the alternate interior angles, and not just list them, but let's actually say that they're equal to each other. So I could start with angle 3. What would I say angle 3 is equal to because of alternate interior angles?
7.
Angle 6. Well, 3 and 7 are equal, but because of alternate interior angles, 3 equals 6. Why does 3 equal 7? Give me a reason why 3 equals 7. They're corresponding angles, okay? But 3 equals 6 because of alternate interior angles. You follow me? What else is equal because of alternate interior angles? 4 and 5. So let's write that down. Angle 4 equals angle 5 because they're alternate interior angles as well. Everybody with me? That's not so hard, is it? What other alternate thing did we have? Let's take a look at the alternate exterior angles. See if there's anything true about those. Look at angle 1. What's an alternate exterior angle with angle 1?
8.
Angle 8. What's true about those two angles? They're equal to each other as well, aren't they? So guess what we can say now? Alternate exterior angles are equal. Looks like everything's equal, doesn't it? Or you could put congruent. So let's list the alternate exterior angles. We already said the first one. Angle 1 is equal to what? Angle 8. Give me the other one. 2 and 7. So angle 2 equals angle 7. Or you could say congruent too. That's fine. These right here, the alternate interior and alternate exterior, we got all that because of the corresponding angles. We knew that if we knew that corresponding angles were equal to each other, and we know that vertical angles were equal to each other, we kind of figured out on our own, didn't we, that 3 and 6 were equal, and then that 4 and 5 were equal. These things are called theorems. Theorems. Okay, they're called theorems. This is a postulate. Remember, a postulate is just an accepted fact. Okay, we don't have to prove a postulate. Just somebody told us, okay, that that's true, so we can agree that that's true. A theorem, on the other hand, can be proven. All right, we figured out on our own, didn't we, that 3 and 6 were equal and 4 and 5 were equal. All right, we figured out on our own that alternate interior angles are equal and then alternate exterior angles are equal. It's a slight difference, and we call those things theorems. All right, so when you look in the book, you'll see this one as a postulate. You'll see this one as a theorem. And they're all numbered as well. We don't have to memorize the numbers of these theorems and postulates. Okay, I just want you to understand what they say, what they mean, what they do. Everybody with me on that? Let's do one more. Now, this is not quite as easy to see, but tell me something about 4 and 6. What's the relationship? What's the name of 4 and 6? Consecutive interior angles, okay? So watch. I'm going to write this down. I'm going to write consecutive interior angles. Now look, corresponding angles were all congruent. Alternate interior angles were all congruent. Alternate exterior angles were all congruent. What do you think is going to be true about consecutive interior angles? You would think, wouldn't you? But let's take a look at them, though. Look at angle 4. What kind of angle is angle 4? It's obtuse. What kind of angle is angle 6? It's acute. Is there any way that an obtuse could equal an acute? No, there's not. Okay? Watch this. Look at 3 and 4. Everybody watching me? I got a minute to explain this, so just pay attention. 3 and 4. What's true about 3 and 4? It's a linear pair, so they add up to what? 180. Watch. 3 and 6 are equal to each other, right? So if 4 and 3 add up to 180, what do you think 4 and 6 do? They add up to 180 as well, don't they? Because 6 and 3 are the same exact angle, right? Okay, so 4 and 6 must equal 180, and they do. So 4 and 6 are equal to 180, so what do we say? We say that they are, what's the word? Supplementary, not congruent. They're supplementary because they add up to 180. So what can we say? We can say that angle 4 is supplementary to what? Angle 6. And quickly, angle 3 is supplementary to what else? Angle 5. Why? Because consecutive interior angles are not congruent. They're not equal. What are they? They're supplementary. Thank you. That's it for that.